Hello everybody. So for our first review assignment during this off period, we're going to work on our review of transformations. So the first one says, using the coordinate plane, which of the following statements would result in figure ABCD being in quadrant number 2? Well, the first thing we need to remember is how we label our quadrants. So it's always start in the top right, and then you make a C. So that would be 2, 3, and 4. So now that we have our quadrants labeled, we know our shape has to end up in this upper left-hand quadrant. So if we look at each answer choice, some of them are reflections, we've got some translations, and so on and so forth. Now, if we do figure ABCD is reflected across the x-axis, well, that's going to give us a shape that is down here in the fourth quadrant, so we know that one's out. Second one, figure ABCD is reflected across the y-axis. That's going to give us right there. So that one looks to be pretty good so far. We have a figure ABCD is translated 4 units to the left and 2 units down. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. And that's going to give us that sort of shape. Now, it has it partially being in quadrant 2, but it's also in quadrant 1 still as well. And then if we look at the last one, figure ABC is rotated 90 degrees about point B. That's going to give us a shape that looks like that. That also gives us part of our rectangle being in one quadrant and part of it being in another. So the only one that works completely to put it into quadrant 2 is choice number 2. Which regular polygon has a minimum rotation of 45 degrees to carry the polygon onto itself? So we need to remember, whenever we're talking about minimum number of degrees, it's 360 divided by n, where n is the number of sides. So as we go through, if we take the octagon, 360 divided by 8, that gives us 45 degrees. So that seems to be our answer, but let's just go quickly through the others. Decagon, 360 divided by 10 is 36. Hexagon, 360 divided by 6 is 60. And pentagon, 360 divided by 5 is 72. Now remember, the key is it says minimum rotation. If it just says which polygon can have a rotation of 45 degrees, or if it leaves out that word minimum, then you need to remember that each multiple of those numbers is also a degree measure that works. But again, if it says minimum, that's going to be that first number that you get. If triangle A prime, B prime, C prime is the image of triangle ABC, under which transformation will the triangles not be congruent? Whenever you see the word not congruent, there's 4 transformations. There's only one of them that's not congruent. You automatically want to look for the dilation. Now you want to be careful if your scale factor is equal to 1, all right? Because remember, if scale factor is equal to 1, then it actually is congruent because your shape doesn't change size. But in this case, if it's a scale factor anything other than 1, then we know that's going to be the one that's not congruent. Number 4, in the diagram below, a square is graphed on the coordinate plane. Which reflection does not carry the square onto itself? So, if we go choice by choice, the first one, x equals 5, is this line right there. Well, if we reflect over that piece, we're going to end up with a square over there. So it looks like we found our answer probably right away, but let's take a look. Y equals 2. The line gets a little bad towards the end there, but the line y equals 2 is right there. That clearly splits that square in half, so as you reflect it over that line, it's going to end up right on top of itself. Y equals x. Y equals x goes corner to corner, and in a square, if you go corner to corner and make a diagonal, it will land on top of itself. And then the last one's a little bit screwed, but if you put it into y equals form, you get y equals negative x plus 4. That's this line right here that forms our other diagonal. for the same exact reason that y equals x has the square carry on to itself, y equals negative x plus 4 is the same thing. So the only one that would not carry it on to itself is x equals 5, because that clearly flips it over to that right-hand side of the graph. And number 5, a sequence of transformations maps rectangle ABC onto rectangle A double prime, B double prime, C double prime, D double prime. Which sequence of transformations maps ABC onto A prime, D prime, and then the prime onto the double prime? So the key is to look and compare the two. If we look at what happened here, you can see A and B on top, and then A prime, B prime are on the bottom. So that's clearly a reflection. You can also check orientations where you have it clockwise, and then you have it counterclockwise. Remember, if your orientations are flipped, that means a reflection has to be a part of it. And then obviously to go from prime to single prime, if you're going to have that spin like that, that's obviously got to be a rotation. So the answer is going to be choice A, which is a reflection followed by a rotation. Which sequence of transformations maps triangle ABC onto triangle DEF? Well, again, if I'm trying to figure out what maps one onto the other, the first thing I usually check is my orientations. So I've got counterclockwise and counterclockwise. So that means it either has to be no reflection or a double reflection, but it cannot be a single reflection. So right there, just by checking my orientations, I've eliminated B and C. So if I look, choice A says a reflection over the x-axis, which gets me up to here. And I'm not going to have it perfectly exact. And then a reflection over the y-axis, which that looks to be a pretty good answer choice. As I take a look here at the last one, choice D, if I translated 8 units to the right and then a 90-degree counterclockwise rotation, 1, 2, 3, 4, 5, 6, 7, 8, and 1 up, we're going to end up with a shape that looks kind of like this, A, B, C. But if you look, what's supposed to match up? A and D are supposed to match up, B and E, and if you rotate 90 degrees, you're going to get A to be up there by F. So that one's out. So the only one that works for this one is a reflection over the x-axis, followed by a reflection over the y-axis. For number 7, the image of rhombus VWXY preserves its properties under the transformation. So it's a translation 2 to the right and 3 down. So remember, when you slide something, such as a rhombus, what does it look like? Well, when you do that, you end up getting a shape that's facing the exact same direction. So its orientation doesn't change. Remember, orientation is the order of the letters. And parallelism means if it starts parallel, it stays parallel. So both of those are going to be preserved under a translation because all you're doing is sliding it. You are not flipping it, you're not spinning it, you're not doing anything. You're just literally sliding it across the graph, across your paper, wherever you are. So both parallelism and orientation are going to be preserved. For number 8, the triangles are congruent and describe a sequence of rigid motions that maps them on top of each other. So there are a couple different options here. I know it says sequence, but sequence doesn't actually have to be multiple. So the first thing, again, I always check is A to B to C. We're going clockwise. And then it says STU. So STU is also clockwise. So again, it's either double reflection or no reflection whatsoever. To me, this looks like some sort of rotation. And if I look at it and I center it at the origin, if I were to rotate 90 degrees about the origin, I would end up with B matching up with T, which is supposed to, A with S, and C with U. So my answer here is going to be a rotation of 90 degrees about the origin. And again, another way that you can put that is a rotation about the origin of 90 degrees. But remember, for a rotation, you need multiple pieces. You need a number of degrees, and you also need a center. For number 9, As graphed on the set of axes below, triangle A prime, B prime, C prime is the image of ABC after a sequence of transformations. Are they congruent? And use the properties of rigid motions to tell. Well, when I look at this, I can see that in order to get ABC onto A prime, B prime, C prime, the first thing we do is we reflect over the over the y-axis, and that's going to give us that shape right there. And then we are going to translate everything 3 units down. So if they want to know if the triangles are going to be congruent, if we state those 2 transformations, then we can talk about what type of transformations those are. So since a reflection over the y-axis and a translation 3 units down are both rigid motions. Now remember, if you're going to say rigid motions, you have to say which preserve size and shape. Triangle ABC is congruent to triangle A prime, B prime, C prime. So basically what they wanted to do for that one is figure out that triangle ABC and A prime, B prime, C prime were formed based on a reflection and a translation, and that those 2 are rigid motions which preserve size and shape. For number 10, it wants us to do a composition. So remember, that open circle right there is key because that tells us to work from right to left. So I'm going to start by writing out my original coordinates here. A is -2, 2, B is 3, 5, C is 4, 2, and D is -1, -1. So I'm going to graph that as well. Now I know it says the use of the graph is optional, but it usually makes your life a lot easier if you actually use the graph. So A, B, C, D. So if we're going to work from right to left, the next thing that we're going to end up with here is A prime, and we're going to end up doing the translation of 2, -3 first. So that's going to give us that we're going to go right 2 and down 3. So right 2, down 3, right 2, down 3, right 2, down 3, and right 2, down 3. So there's A prime, B prime, C prime, and D prime. So we've got 0, -1. We've got 1, 2, 3, 4, 5, 2. We have 6, -1. And we have 1, -4. Then for the last piece, as we finish this, we're going to end up doing our reflection over the y-axis. And if we remember, what that does is it takes all our points and flips it. Now that point A is on the y-axis, or A prime, excuse me. So therefore that's going to be what we call invariant. It is not going to move because it's on the line of reflection. So for B prime, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So there's B double prime. C double prime is going to come out here, and D double prime is going to be there. Now, we have to make sure it says state the coordinates. So if you do not write them down, you will not get full credit for that question. So as we finish this up here, we have A double prime is 0, -1. B double prime is -5, 2. C double prime is -6, -1. And D double prime is -1, -4. So remember, when you have that composition symbol, you want to make sure that you are working from right to left. So we did the translation first and the reflection second.